All right, let's talk about conditional statements. A lot of this is related to or comes from chapter 5 in the Advanced Art textbook. There's also a bit covered, in chapter 3 of this textbook, which you should be able to access for free if you're connected to the UCLA VPN. Okay, conditional statements are basically statements that have a condition, basically your if statements, but they also play a role in, say, like a while loop, because those are based on a condition. And so the way we evaluate a condition is we need a logical value, true or false. If it's true, the related lines of code get run. If it's false, those lines of code do not run, and therefore we need to know what operators produce these logical values, true or false. Okay, the logical operators that we have are basically and or. We also have not, which reverses, switches the operation, false or the true. And then we also have exclusive or. If you use a logical operator, that is going to coerce anything that is not logical to logical type. But basically, the only thing that becomes a false is a zero. Zeros become false, and pretty much all other numeric values evaluate to true. So that's something you have to be aware of. Okay, all of these logical operators are vectorized, and so if you have two vectors of values, it will match them up element-wise and also perform recycling. Okay, and then the result will be a vector of logical values. We also have non-vectorized logical operators. Okay, we have the double or and the double and these only accept values that are length 1, and if you give it something that's longer than length 1, it's going to return an error. Okay, if y has a length that's greater than 1 and is evaluated, that will, x and y, they will both return an error. But if y has a length that is greater than 1, but it is not evaluated, r will not return an error. And so I'll show you an example of what that means. Okay, older versions of r will actually read left to right and allow for things that allow for vectors that are longer than 1, and will only evaluate the first one. But you should have, I would say, update to the latest version of R and have kind of the updated operations here. So here I have x and y. These are vectors. X is true, true, false, false. Y is false, true, false, true. And if I use the single or, that's going to be vectorized. And basically with or, if either one is true, it will evaluate to true, and it's only when both are false that evaluates to false. So true, false is true, true, true is true, false, false evaluates to false, false or false, and false or true is true. Meanwhile, with and, both things have to be true for it to be true. So true and false is false. True and true is true. False and false is false. False and true is false. Here we have an or operator. It is the non-vectorized. And so giving a vector that is longer than length 1 results in an error. Okay, error in x or y. It's trying to coerce this into length 1 logical, and it can't do that. Okay, here if I have a false and the double and y, okay, it doesn't need to evaluate y, because as soon as the and operator sees the false, it knows that it's going to be false. So it doesn't even bother evaluating y. So even though y has a length longer than 1, y is not evaluated, so it doesn't produce an error. Okay, if you have a true with or, okay, then r also knows that the result is going to be true. It doesn't need to evaluate y. So even though y has a length longer than 1, it doesn't produce an error. Okay, here if I have a false with the non-vectorized or, okay, now it needs to evaluate y, and now it needs to know if y is true or false in order to produce its answer. And so now that y gets evaluated, it notices that y has a length greater than 1, and therefore it returns an error because it sees that it has a length greater than 1. Okay, when you have an NA, okay, NA is a missing value, and R treats that as unknown, but it can still kind of evaluate. So if you have true or NA, it doesn't matter what this is, because if there's a true, then the result of true or something else, it doesn't matter, is going to be true. On the other hand, true and NA is going to remain unknown because it matters what this is. If NA is true, it will be true. If it's false, it's going to be false. So it matters what this is. A false or NA is unknown. Okay, the result of that's going to be unknown because we need to know whether the NA is false or true in order to evaluate that. However, false and NA we know is going to result in false. So, so the operations there depend on whether you're using an or and an and whether you have a true or a false or things like that. So true or NA will be true no matter what the NA is. True and NA is unknown to us. False or NA is unknown to us, but false and NA we know for sure is going to evaluate to false no matter what NA is. Exclusive OR requires that one thing, X, is true or Y is true, but not both. Okay, so if you have X OR and you have a true and a true, that's going to evaluate to false. So true exclusive OR false is going to be true. True exclusive OR true is going to be false. False exclusive OR false is false. False exclusive OR true is going to be true. And then if you do an exclusive OR with missing values, they're all going to be missing because it matters what that missing value evaluates to. You have any and you have all. Any is kind of like the generalization of the OR to more than two values. All is the generalization of the AND to more than two values. And so basically everything has to be true for all to evaluate to true, and any one of the values has to be true to evaluate to true. So here I've got U, everything is true, any is true, all can be true. If you have true, true, false, the any will evaluate to true, and the all will evaluate to false. If you have false, 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 any evaluates to false and all evaluates to false. All right, so here's a question that you should think about, okay? If we have a zero-length vector, like logical zero or null, and if we add it to a vector of logical values v, then it shouldn't have any effect on the result of any or all. That is, if I do any, and if I have a v, and I have a logical zero, I add logical zero, then the result should just be the same as any applied to v, because logical zero is basically nothing. Okay, same thing, same idea with all. Okay, if I have all on v, and then I throw in a logical zero, basically I'm adding nothing to the thing, the result should still just be the same as all v. So with that in mind, what should any on a zero-length vector return, and what should all on a zero-length vector return? Okay. You can pause the video to think about this. What should any on a zero-length vector, or what should all on a zero-length vector return? Let's take a look. Okay, so X is going to be a length 0 logical vector, and if you apply any on a length 0 logical vector, that's going to evaluate to false. Okay, why is that? Well, if you think about it, if I have true, 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 and I evaluate any on the true, that would be, that evaluates to true. If I combine the logical 0 to the true, 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 that should be also true, okay? If I have true, true, false, and I throw in any on there, that evaluates to true. If I add the length 0 logical vector to this, so true, true, false, and a logical 0, that still evaluates to true. Okay. Here I have false, false, false. Any on the false, false, false evaluates to false. And if I include the length 0 logical vector, any on the x, the logical length 0 logical vector, and w, that thing also needs to evaluate to false. If any on logical 0 somehow evaluated to true, then this thing, any combining the logical 0 and the w, would then evaluate to true. And so it's important that any unlogical 0 evaluates to false, so that this rule holds up. Okay, and with the same kind of reasoning, all applied to a length 0 vector is going to evaluate to true. Okay, so here I have x is now a length 0 vector. All applied to that is going to be true. And so all applied to u, which has true, 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 is going to be true. And then if I combine the length 0 logical vector with u, it should evaluate to the same thing. Basically, I'm adding nothing. But somehow, if the length 0 logical vector on all evaluated to false, then this thing would end up being different. Okay, all of these other things remain kind of false, and so they evaluate the same. But throwing in a length 0 logical vector shouldn't affect the result of the evaluation of all, and so all applied to a length 0 logical vector is going to evaluate to true. We also have comparison operators. These comparison operators produce logical values, and they are vectorized, and they also perform recycling. So you can check to see if two quantities are equal to each other with the equals. You can check if two quantities are not equal to each other with exclamation point equal, not equal, less than, greater than, less than or equal to, greater than or equal to. And then you also have the in operator. Okay, and so x, it's vectorized for x. So if you have like 20 values in x, it will produce 20, a vector of length 20, and it will check to see if any of those, if the element in x is one of the values in vector y. If you have character strings, okay, comparison operators are based on alphabetical order with the following general arrangement. We have symbols, okay, and then the digits starting with 0 and then 1 going up to 9, then lowercase a followed by capital A, then lowercase b followed by capital B, continuing until you reach capital Z. All right, so one side effect of this is that the character string 10 comes before, is alphabetized before the character string 2. Okay, 10 is alphabetized before 2. Okay, of course, if you look at the numeric quantity, 10 is not going to be less than 2. 10 comes after 2, so 10 less than 2 is false, but the character string 10 comes before the character string 2, and so character 10 less than character 2 evaluates to true. As far as the symbols, this is the order of the symbols. Okay, and here I wrote backtick, but that's the basically the little backtick that's above the tab key on your keyboard. We also have is functions that can check to see if something has a certain kind of, is a certain type or class or trait or whatever it is, and these will return either true or false statements. So is something missing? Is it null? Is it atomic? Is it a factor or whatever? These will return true or false. So now that we can create or produce logical values, we can throw those into conditional statements. So the if statement, okay, is how we execute code blocks, all right? Conditional execution of code using the if statement. So basically you have if a condition, and that condition that goes inside an if statement must produce a length 1 logical value, okay? Length 1 logical vector, and it cannot be NA, it cannot be missing, okay? If you have, if this conditional thing is a length greater than 1, that's going to result in an error. Older versions of R allowed for it and gave you a warning where only the first element is used, but basically the newer versions of R said, you know, that doesn't really make sense. So it results in an error, okay? Other types of things, and if you throw it into a conditional statement, will get coerced into a logical thing if it's possible, but generally you really want to kind of make sure it's a logical value in there. If the condition results in a missing value, you will get an error. If the condition is length 0, you will get an error. And then as far as the expressions that run when that condition is true, you generally put them in curly braces, but if there's only kind of one line to execute, then the curly braces are optional, but it's good practice to use the curly braces. Okay, so here I have this vector x. It's got the values 1 and 3, and we can run this operation. 1% in %x is a value that's inside the vector x. That is true. And so I can write a statement. If 1 is in x, execute these code. The code says print hello. And so this statement is true. And so we print out hello. Here is, we get an error if we have a logical vector with a length greater than 1. So here I have x is the vector 1 and 3 again. And now I can say, is x less than or equal to 2? Well, it's true for the first value and it's false for the second. So we have this comparison operator. It's vectorized. So it says, is 1 less than or equal to 2? That's true. 3 less than or equal to 2? That's false. If we throw that in here, we get an error because x less than or equal to 2 produces a length 2 logical vector. And so it says error in if x less than or equal to 2, and says the condition has a length greater than 1. So error messages in R are helpful. When you encounter an error message, don't just throw up your hands and say, uh-oh, something broke, but read it and see if you can figure out what went wrong. So here it says the condition has a length greater than 1. What is the condition? X less than or equal to 2. So you go, oh, you know what? Something's going on here. This thing is producing a logical vector with more than one value. If you do want to have a vector greater than 1, then you should wrap it in any or all. So now if I do x greater than or equal to 2 with a 1 and 3, we're going to get a length 2 logical vector, but I can wrap it in any, and now this becomes a length 1 value of true, and then I can throw that in there. If any of x are greater than or equal to 2, then run this code which says print can you hear me now, and that works. Okay, which over here we got the error, so that line of code never ran. If you throw in an NA, okay, so here I have x is the values 1, 2, 3. We're going to ask for the fifth value. The fifth value in x, is that greater than or equal to 2? Okay, well, x square bracket 5 is going to produce an NA, or so we're asking if NA is greater than or equal to 2, well, that's going to result in an NA, okay? Because if you're trying to compare an unknown value, the result of that comparison is unknown. And so you get an error. It says error in this if statement, x number 5 greater than or equal to 2. It says missing value where true false needed. So that happens. Missing value where true false needed, that's going to be a very common error that you'll run into, and that means you have a missing value. Okay? And you need to go through your code, figure out why this thing is producing a missing value. Here it's easy to see. We're asking for the fifth value, and there's no fifth value in here. This kind of stuff could happen a lot in your loops. So you might have some kind of loop, and you say, hey, do I plus 1, and I keeps counting higher and higher, and maybe you don't have your stopping criterion set correctly, and so maybe the original vector is length 10, and I reaches 11, and now you're asking for the 11th value, and that 11th value doesn't exist, and so you get an NA, and then you encounter some kind of error message. So again, read the error messages. Missing value where true false needed is going to be an indication that you have an NA inside an if statement. And then once you know kind of what's the source, then it makes it easier to track down where something went wrong. If you have a length 0 vector, you get an error. Okay, so here I say x is 1 through 3, and then I ask which value of x is equal to 4. That's a length 0 vector. Okay, so if I say if basically length 0 vector is equal to 4, that condition is going to be it says argument is of length 0, okay? So print, will this work? Well, that's not going to run. I get an error, okay? And again, if statement says argument is of length 0. So that's telling you that something inside of here is producing a length 0 vector. And so so that will be the indication. So read the error messages again, and you get errors for if. So if really only accepts true or false, or the statement inside there has to evaluate to true or false. A lot of times you have these, you might put some kind of expression inside the if statement. I would actually argue, for the sake of making your code readable, put the thing that's going to evaluate into true or false on a separate line, and basically, say, give it a title. If, I don't know, is even, okay? So you're going to say the value is going to be is even, and you'll say that's, set that equal to, basically assign to is even, the less than dash, the arrow sign, assign to is even, and then you have the operation or the expression that's going to evaluate whether something is even. And that's going to assign either a true or false value, and then you put if is even, and then you go through your operation. All right, you can take your conditional statements and you can nest them. So we have if, we have else if, and we have else. If you want to use an else statement, then it needs to, else only works if there's an if statement. And then the if, else is only going to evaluate when the if statement is false, okay? You can also have another condition with an else if, but again, that's going to evaluate only if the kind of starting if statement is false. You got to kind of put the else on the same line as a closing curly brace of the for the previous if statement. Otherwise, R is going to just think the evaluation of that if statement is correct. So here I've got x. We're going to assign 3 to x, and it's going to be if x is less than 0, print negative. Otherwise, check to see if x is greater than 0, then print positive. And if that's not true, then print 0. So for x, assigning 3 to x, this evaluates to false. So we'll go to the else statement. This evaluates to true, so we print positive. Here I have 0, okay? X less than 0, that's false. So we go to the next thing. Else if x is greater than 0, that's also false. 0 is not greater than 0. So, so we skip that. And so the only thing left is else, and so we print 0. If you do something like this, okay, x, we're going to assign 3 to x, and then I say if x is greater than 0, print positive, else if x is greater than 1, print bigger than 1, okay? However, this statement will never get evaluated because there's never a condition. Again, this if statement on this else line is only considered when the previous if statement is false. So there's no situation where this statement is false, x is greater than 0 is false, but this statement is true, okay? So, so if this statement is true, it's going to skip basically everything else. It's not going to run any of the else statements. And so the else is only get evaluated when this is false, and there's no situation where this is false, but yet somehow this is true. So this bigger than 1 will never ever get printed, and that's what's going to happen as far as evaluating that code there. Okay. If is not vectorized. If is not vectorized. It requires a logical vector of length 1. If you have a whole bunch of values, true, false values, and you want to do it, then you have to either run a loop and evaluate the if statement on each of the elements, okay? There's another thing you can do. You can run if else, okay? There's if else, and that is vectorized, and it will evaluate basically this first statement, the test Okay, this is going to be vectorized. Is x equal to 5? And so you could have a vector x, okay, that has a whole bunch of values, and it's going to evaluate true or false. For the values that are true, okay, it's going to pick the yes, and for values that are false, it's going to pick the no. Okay, so that's the if-else is vectorized for this condition, and then it will evaluate this condition for all of the values in x, and then for the ones that are true, it's going to pick the yes, and for the ones that are false, it's going to output the no. All right, so that's that for conditional statements.